and then you'll see it all in action with Kyle's demo. If I can figure out how to change the slide. There we go. There's a little intro to us. Kyle, if you want to do a quick intro to who you are, that would be great.
Sure, yeah. Hello, welcome everyone. My name is Kyle Ruddy. I'm on the technical marketing side of Terraform and basically all things that's infrastructure, so including Packer too. Thank you for joining. Hopefully stick around. We've got a live demo that we're going to be showing off, as well as answering some Q&A at the end. Corinne?
Awesome, cool, sounds good. All right, so as Michelle mentioned, Terraform 1.1 came out in December, right before the holidays, and other exciting news with HashiCorp. And really, to give you a high-level view, the 1.1 release introduces two core themes with their own deliverables that roll up to these themes. The first theme is easier and safer refactoring, and this is made possible with our new moved statements. And then secondly, an improved CLI experience for Terraform Cloud and enterprise users. And this will be shown through the new cloud block that was delivered. Now let's talk about the first theme. We're going to talk about easier and safer refactoring, and first go into how refactoring worked prior to this release, and kind of the pain points that we saw common across different types of users and what we really wanted to target. So how did you refactor prior to this release? As many of you know, the core function of Terraform State is to understand the bindings between resource instance addresses and the remote objects that they represent. So what's out in the real world and what you define your configuration. So if you wanted to do something like rename a resource, it could be a little bit more complicated, because if you go ahead and just change the name in your configuration, Terraform State would understand that you have something out in the real world that no longer exists. It would delete that thing and then recreate it. And oftentimes you don't want to do that. You just want to rename something, or you want to move the location of a module or something of that nature. This is really common. It's especially common when you are growing out your infrastructure and it gets more complex. You have different types. You want to go ahead and group things more meaningfully so you can make changes. So in order to make sure that you update your remote objects and your configuration in the right pattern, you would use something like Terraform State Move. And what that would do is you could go ahead and do Terraform State Move, update your states, and then update your configuration. We'll go into why this was a tricky process for many different types of users and the improvements we made to refactoring. All right, so first of all, this was a pretty risky and error-prone process. So this is assuming you are able to make all these changes. You would go ahead and update your state, make sure that your configuration changes, and if you run into any errors, you are on your own, really. These messages wouldn't come back with a lot of useful information. And you were hoping too, if you're working in a collaborative environment, that no one else is going to create a plan in the middle of when you're updating a state object and haven't updated your configuration, because it could go ahead and destroy your objects and then recreate infrastructure. That's not what you want to do. You don't want to risk the downtime. Secondly, for Terraform Cloud users and Terraform Enterprise users, refactoring tasks really weren't possible at all. Terraform Cloud really operates in the way that changes are made based on plan and like actual configuration changes. So with refactoring, you're not really making actual updates to infrastructure, you're just renaming or moving things in your configuration. So if you were a Terraform Cloud user or an enterprise user, you couldn't do refactoring. What was possible was if you had an admin access on a workspace, you could go ahead and switch to local execution, do your refactoring, and then make your updates, push all your updates. But again, this was risky and error prone, and we don't want to provide these strange out of bound, maybe not in policy operations. We wanted to provide an actual workflow for this. And then lastly, if you're a module author and you're going ahead and refactoring a shared module for your end users, it wasn't really possible to directly refactor modules. You didn't have access to existing state object names. You needed to go ahead and basically release a new major version to indicate a breaking change. And then you'd have to give instructions to your end users about how to manually update their state. So again, pretty cumbersome, not super great workflow. And we really want to provide better tools. So what do we deliver? We delivered these move statements, which are written into your module's source code. So it's in your configuration. And basically, what you're able to do is you can rename a resource or rename a module call. You can enable count or for each for resource or module call. And you can split one module into multiple. And you can see the syntax here. It goes moved from, this is like renaming a resource using that first example that we talked about. And what happens is you can go through, and the first time, once it encounters state and it realizes, okay, we're renaming, we're not updating the actual objects or recreating infrastructure, it takes care of it for you, and now you have this historical record of what has been changed. All right, so how do these move statements solve the problems that we talked about before? It's much easier and safer. So instead of constructing these individual commands that you want to happen in a particular order and hope that nothing goes wrong in the middle, this can all happen with one single apply step, and you can get a whole list of simultaneous refactoring tasks that are taking care of updating state and renaming for you. You can preview, plan, and validate everything to make sure that it's exactly as you intended without having to really do anything from the CLI that is not the greatest workflow. Secondly, our Terraform Cloud and enterprise users can now refactor within their workflows because now it is part of the plan process. So it's based on the configuration itself. And then lastly, module authors can now refactor their modules as well. So instead of delivering those manual instructions to their end users, you can just refactor. And then if someone inherits that module and encounters a state with those previous names, it just knows to update and runs. Otherwise, those move statements just stay as is. Okay, now let's talk about the second deliverable. This theme was these improved CLI experience or developer experience for Terraform Cloud and enterprise users. All right, and to start, we're going to talk about the previous way to integrate with Terraform Cloud. So previously, if you were using the CLI-driven workflow, you would go ahead in your configuration and declare a remote backend. And then you can define your host name, your organization, and then you can either define workspaces with a name, so working with one single workspace, or if you're working with multiple workspaces, you can give prefixes. So in this example, what we're giving is a prefix, my app. What would happen is you would go ahead and let's say you create a workspace called dev. What would show in the UI when you do a plan and apply, you would see my app -dev. So it's a little bit clunky because you're thinking I created a workspace in dev. I'm not really seeing what I created. And on the CLI, you say, workspace select, what am I looking at? Workspace list, it would just list dev, not the prefixes. So we wanted to clear up that complication because really the mental overload of having to understand prefixes in order to organize your workspaces wasn't really, really great for a lot of our CLI-driven workflow users. Okay, so let's talk about other issues. The error messages for people using the remote backend were fairly vague. It would just point to this generic remote backend rather than understanding that you're directly interacting with Terraform Cloud. So we wanted to improve that developer experience so you could actually surface, gain context for your actual errors and resolve the issues as quickly as possible. Secondly, the understanding of what a remote backend versus standard backend was pretty confusing, and we wanted to just make it clear to users. So for those who aren't aware, Terraform Cloud, if you're using it locally and you haven't declared a backend, you're just going to be storing your state locally. So you can declare a remote backend or something like an S3 backend. If you're using Terraform Cloud, that would be that remote backend. And you would need to understand that in this case, remote backends mean that you were doing remote operations and storing state, whereas all the other backends were just for state storage. And so we wanted to kind of take that away from the confusion and say the cloud integration itself does remote operations and state storage, whereas the rest of the backends are really just for state storage. And then lastly, as I mentioned, with Terraform Cloud Workspaces, they're not very intuitive from the CLI. You also couldn't use things like expressions, workspace, Terraform.workspace within your own configuration to reference the workspace you're using. And we wanted to fix that right away because many people don't want to have to change the way that they work with their configuration. All right, so here we are. This is the new syntax for the Terraform Cloud integration. So rather than a remote backend that is in its own configuration block, this is a cloud block that's in the Terraform top level settings to say, you're now using Terraform Cloud, this is your organization. You can define names if you're working with a specific or a single configuration. If you're using tags, you can have a list of tags that you want all of your working configurations to use these tags, which is a much better experience than using prefixes. And then for some other benefits and improvements we made, we have better error messages. You now understand that you're working directly with Terraform Cloud. They give you Terraform Cloud specific prompts to resolve errors where you need to go change things. It'll be easier to understand when Kyle shows the demo, but there's a lot more CLI prompts in order to migrate from an existing backend, as well as if you wanted to go ahead and name a workspace directly from the CLI, it allows you to do that rather than you having to construct all the commands yourself. Secondly, remote operations and state storage are finally clarified. The cloud block itself, that refers to remote operations and state storage, whereas all other backends are just for storing state. And then lastly, Terraform Cloud Workspaces are more intuitive. So you can use names and tags to manage your workspaces, and it'll show exactly the same thing in the UI that you see in the CLI. And also another thing that's mentioned here, we now support per run variables. So you can use the dash var flag from the CLI, whereas previously you would need to go into the UI and configure the variables themselves on the workspace. So you can have more iterative development in that case. All right, now I'm going to pass it over to Kyle, who's going to do a demo so you can actually see everything that I'm talking about.
Excellent. Thank you very much for that, Corinne. So that was a lot of information about, essentially what boils down to two different feature sets that we've released as part of Terraform 1.1. So let's jump into our demo environment here. And we'll start out by showing pretty much, if you've seen some of the prior Terraform demos that I've done, you're probably well acquainted to this theory of a web application that's just setting up a very basic web application that's just basically a picture saying hi. And so we're going to take that and kind of build on that with some of what we've gained as part of Terraform 1.1. So what we have here is we're going to be working with Azure, as well as working with HCP Packer, which is currently in a beta release, so that I can source all of my image templates, my artifacts from HCP Packer and use it, introduce it into my Terraform configuration so that I can, I don't have to go through and apply updates every single time, kind of streamlines that process. And from that point, we have a whole laundry list of things that we've created and modified and, to set up that single web application. So looking at our Terraform run that I ran just before this webinar started, we have 11 different resources that we're managing with Terraform. And with that, we have created this web application that is available at the following web URL. In this case, it's a Hashi app, and a HashiCorp Packer is saying hello from a virtual machine by the name of Ruddy Hashi app web admin or web app VM. So from this point, what I want to kind of do is build on this web application. I've heard several, or rather, formerly, I used to run this web application with things were a little cuter, a little furrier, a little fuzzier in terms of different animals. So it used to be either Hashi cat or Hashi dog. And then I built it out to be this. So I want to take this configuration and I want to start introducing modules so that I can do this in a more repeatable fashion. But I don't want to interrupt the web application that's already out there and existing. So we're going to hide our terminal there, and we're going to switch branches from our base branch here over to our, we're just going to create a resource group module, something fairly basic, pretty minimal. However, it has large ramifications if we were to actually change this while everything is running. So here's our module statement there, fairly easy, fairly straightforward. Same thing for our module block, just creating that one single resource with a couple different outputs. However, if we go into our Terraform configuration here, we're going to need to do another Terraform initialization, load up our module so that we can kind of have an understanding of what's going on, and then we can do a Terraform plan. So the plan is going to go through our web application that we've stood up, check out that new module that's out there and go, hey, so about this, we're going to need to change some things. So in this case, it's seeing that we no longer have that original resource group. So that one needs to be destroyed. And we now need to create a resource group that's part of that module. However, again, if we destroy this resource group, everything out there is going to be destroyed as well, which is going to have a ton of change, ton of impact to our web application. And if this was something a little more, production worthy, that would impact our SLAs, and we don't want that. So now we're going to take advantage of formerly what we would do is use Terraform state move, and then we could move from this particular object over to here in our module. However, as Corinne kind of went through, it's kind of error prone, might run into some issues. This one's fairly basic, so probably not, but you lose the history around what happened to this resource. So if we're going back and we're looking at our source control, we're going to lose it. We're going to have no idea what the difference was in between those things. And that's what we want to change with our moved block. So here we're going to switch over to our different branch that's out here. And here we happen to have a new file. It's called Refactor. So what this Refactor file is containing is just a move statement. And then if we remember our terminal output here, we're just saying that we're going from this item right here, this resource, which is the one that was going to be destroyed, and we're going to move it into this one that's going to be created. So very simple, straightforward. Again, pretty easy from that concept. But the real power here is that now we have this in a codified manner, and it's saved out to our version control. We have an idea of what's going on behind the scenes. So if we go ahead and do another Terraform plan, we will be able to see that instead of destroying and recreating something, this is actually going to move the item within our state file over to our new item as it's been declared through our module, and then is not going to change anything else to our actual infrastructures. There's no additions, there's no changes, there's no destroys, right straight off the bat. So now we're going to do a Terraform apply. And for the sake of time, we're just going to go scream right straight through the approval process to have that update and move our resource from one area to the next. Now, again, we see our move statement that's right here. It's going to perform those following actions. And then there we go. Nothing's changed, nothing's added. All we've done is make some modifications to our state file. Just as a verification out here, we're going to hit our refresh button, see our website still running, still talking to Packer, still all good from that aspect. So now what we want to do is get a little more complex. Actually, what I want to do, let's go back to our other branch before we get into the more complex option. As we can see, source control removed our refactor Terraform configuration there. And if we do another Terraform plan, it's going to go through, refresh itself just for just a second there through Azure. No changes. Everything's good. State file is up to date. Our configuration is up to date. Still using that module. We're all set and running. All right, so now let's get to the more advanced method here. So we've standardized, we formalized on our web configuration, that standing up our web application, as well as our the actual deployment therein of our website and services itself. So we still have our configuration here. We're still making use of Azure. We're still making use of HCP and therefore HCP Packer. But we've broken out our configuration into two separate modules. One is just standing up our web application in a templatized fashion using Azure Resource Manager. And then our other part down here is a breakout of our web configuration, meaning that we can reuse this web configuration module for every single other cloud service that's out there, no matter if it's AWS, GCP, pick anything else that can host a virtual machine, we're all set there. And here, just for verification here, I mean, we're pretty much just running through a couple different resources that we're shuffling through our variables. And then in the end, underneath the covers, it's just a remote exec. So that's why I can kind of move in between all the web services. But now that we've modified all of this, we've changed it, we've put everything behind reusable modules. If we go ahead and do a Terraform plan, need to do a Terraform initialization first, install our modules there. Now, if we do our Terraform plan, we're going to see that a whole bunch of stuff has changed. Like there's a lot of impact by moving from that one configuration into this one that's being drastically modularized. So we've gone from our 11 different resources. We're going to destroy those 11 resources and recreate 11 resources. Again, that's going to impact our SLAs. It's going to impact all of the resources that we have out there and are under management, and we don't want that. So here, as we kind of scroll through, we can see certain things like our virtual network here is going to be created. If we keep scrolling up, you can see our virtual machine, a resource group that was going to be destroyed, our shuffle, there's our other virtual network there that's being destroyed. So we can see the output from all of this within our Terraform plan here. But again, we don't want that. We're going to take a look at what our refactoring or what our move statements are going to look like for this particular configuration. So again, we toss it into a refactor configuration file. However, you can put this wherever you want to. If you want it in your main.tf, that's fine as well. I'm just separating this out for ease of use. So here we could go through all of those 11 things that needed to change, moving from our resource into our resource based in the module itself. And then the one big thing that I want to call out down here is we can even move between modules. So we're going from our old ARM_RG resource into our new ARM Web App module, all without having to really impact anything at all. So going back up here, let's clear this out and do another Terraform apply and let that rip. So now it's going to take into consideration that refactor.tf file and say, hey, we see all these things, all these other things need to be moved over to that, and it's going to go ahead and do that for us. We can see the output there of all these different things. Our shuffle that's being moved over, a random generator there. Here's our network is being moved over from resource to module based resource. And now that that's complete, everything's changed, but it hasn't touched our infrastructure. Infrastructure still remains intact. It's still live. If we wanted to come back over here, hit refresh, still talking to Packer, still all good. Same thing, if we jump back into our full refactor, can do another Terraform plan. It's going to see everything is all good. Everything is the same. We're ready to roll. And there we go. Okay, so now we're going to jump into the second feature that's available as part of Terraform 1.1, and that is our cloud integration. So if some of you are familiar with the backend and remote backend, which hopefully you all are, this is a really cool way to add in some new features that you might have been asking for before. So here, switching branches over into our cloud integration. So we can see up here towards the top, we have a new cloud block that's now available in our Terraform block. And what we're doing here is we're talking out to Terraform Cloud. Our organization is going to be named PMM Organization. And then here we have our Workspaces block. Here we can either dedicate a very specific name, or we can use tags. And tags allow us to get a little more dynamic in the usage and consumption of Terraform Workspaces. So again, we're going to clear this out and do a Terraform initialization. So here we should be able to, there we go, we're initializing Terraform Cloud. It's asking us, do we want to migrate our state from local out to cloud itself? Of course we want to do that. And now it's asking us for a name. So again, that's because we didn't specify the name as part of that cloud integration block. So we're going to give it a, sorry about Visual Studio Code kicking out the top of my terminal output there. So we're going to give it Ruddy Hashi App Web App. There we go. So now it's going to go through, initialize those provider plugins, upload our configuration up to Terraform Cloud, and make that available in our organization. So now we're out here. This is our organization, again, PMM organization. And now we have this Ruddy Hashi App Web Application. We see our Service Azure and our Web App tags that are now out there available as part of this. Its latest change was just a few seconds ago, meaning that it just updated itself. We can already see some of the things that have been uploaded and been made available as part of our state tab here. So now let's go ahead and kick off our, come back, there we go. All right, so now let's go ahead and kick off a Terraform apply. Actually, let's clear and do Terraform apply. So you can see what's going on behind the scenes now that we've migrated out to Terraform Cloud as part of that cloud integration. Oh, I need to move my state file because it copied it up there. So that's going to be the one that it uses. In our local environment is still going to try and use that. All right, there we go. So we can see what our run is going to be right there. So if we jump out to Terraform Cloud, we can see the previous one that errored because we still had that state file local. So it's a little confused on what it's supposed to be using as its source of truth. Now that we've updated that, you can see that our latest run is out here. It's updating itself from those different modules that we made available. It sees that there are no changes to our configuration there. And so that's going to take just a second to complete running. But again, we have a visualization of all of our resources, those 13 items that were made available through our local Terraform runs, as well as the outputs that are there, still allowing us to get out to our web application here. Refreshing that again, we're still talking to Packer. So again, nothing has actually changed with our infrastructure itself. So now let's get into some cool stuff. Let's get into something that wasn't available as part of the enhanced remote backend. So let's go ahead and clear that out. Let's start talking about Terraform Workspaces. Those of you who have used open source for a long time and also use Terraform Cloud, you know that there's a little bit of a difference between local workspaces and remote workspaces. So let's list out what our workspaces are here locally. So we have our Ruddy Hashi App Web App. So now what we want to do is go back to our roots and create the HashiCat application. So we're now going to do a workspace. We're going to do new and then Ruddy HashiCat Web App. So what that's doing right now is if we jump to our Terraform Cloud console here, we can now see that it has created that Hashi app or HashiCat application out in Terraform Cloud, even though it's literally just a workspace. It's also available here locally. So it's linked those up. So workspaces in your local environment are going to operate the very same way as they do in Terraform Cloud. Now we're going to build on top of that because now we can kind of see some of the integrations that are really coming into play here. So now we're going to do a Terraform apply. However, we want to update our variables. So this was another thing that you couldn't really do when using remote backends, or at least the enhanced remote backends. So we're going to do app type. and change this from the default, which is Hashi app, over to HashiCat. So now again, this is going to kick off within Terraform Cloud through that remote operation. We can see that through the URL that's here, we can either click on it or just go over to our Cloud Console. But there's our planning that's kicked off. It's running and it's going through that process right now. So we can watch that both either in Terraform Cloud or locally with our open source side. We could see that our outputs are changing. So now we have HashiCat for both our demo name as well as our VM name. However, here's another good integration. So if you have approval workflows in your Terraform workflow, you can now also use Terraform Cloud to go ahead and say, you know what, this all looks good. Yep, there we go. Confirm plan. And now we're going to be able to see that's impacted within our Terraform Cloud environment, as well as locally we have our approved using UI or API. So then that's going to kind of run through the process of deploying all that information and resources within a Azure environment. So while that's kind of rolling, a couple other things that we should talk about. While remote is the default execution mode, if you do want to change that, that is very easy to do. All you have to do is jump over to settings. There's this execution mode that's available here. You're just changing it from remote over to local. Then everything happens on your local system, but everything is still being sent out to Terraform Cloud. If you don't want to go through that approval process, you can also switch in between auto apply and manual apply. In this case, we're using manual apply, so it's asking us to confirm that. And let's see where we are. Looks like we are almost done with our virtual machine being deployed and being set up there. There we go. So now that we've run through that process, we could go back to our overview. We can see on our outputs, we have a new URL here available. Let's copy that. And in this case, Loki says hello from our Ruddy HashiCat Web App VM. So there we're using the Terraform Cloud or the cloud integration, set up a new workspace and run it. Now, I know from the last time that I did one of these, including HashiCats, I got the comments that not everybody likes cats. So I also made one that's for dogs. So let's clear out a screen again, and we're going to change this over to dog. That again, going to use our same configuration that's there, spin up a new workspace out in Terraform Cloud. However, now I want to use a different integration that's out there and available as part of Terraform Cloud. And in this case, it's our variables tab. So here we can also set variables that are impacted through this cloud integration as well. So now instead of running that locally, I'm going to do app type and change that over to HashiDog. Now, one caveat here, right now, it hasn't uploaded the configuration. It knows nothing about it. So we still need to kick that off locally on our system here. So let's do a Terraform apply and skip through the approval process, which we can still do using auto approve. So again, jumping out here, we're going to see that our latest run is kicking off. It's going through the process of initializing, set up the remote or set up the backend, going through the initialization process to figure out what it needs to do to create our resources out there in Azure again. So in this case, you can see that our resource group name has changed and our virtual machine name has changed. So this is in fact a whole different environment that's out there and going to be spun up here. So while that's going through, a couple of the other things that I kind of wanted to go through here is because of the way that variables work, and now that you can introduce these into your either local or your CLI-based workflow, you can also make use of a new beta that's available called variable sets. And what variable sets allows you to do is create a set of variables, which, as the name implies, but then you can apply them throughout your organization. In cases like this, it would be really great because then I can set up my Azure credentials across all the workspaces that I have set up, so that I only have to input them once, or I only need to reference them once, or if anything changes, it's only one place that I actually need to change. You can learn more about that by diving into the Terraform Cloud Console and checking out variable sets. So let's see, still in the applying phase, going through our virtual machine that's running out there. So another cool thing that we have available as part of on the Terraform Cloud side is what's known as the contributors. So this is basically setting up role-based access control to, configure who can see, interact, and perform maintenance on these different workspaces that are available in Terraform Cloud. That's another just area where it's in your settings and then team access. And then in cases like this, we have our AWS team, we have our Azure team, we have our CI/CD pipeline process. We can set up our Azure team to then have access to this because obviously it's working with Azure. So let's see if our apply, which should be just about done. There, it's connected, so should be, there we go. So if we go back to our main overview page, click out our FQDN. Run through that, we have a picture of a dog. This one is named Bentley, apparently. And it says hello from our ruddy HashiDog web app virtual machine. So now we've kind of gone through the process of building all this stuff out, but what about the destruction process? Because we created workspaces by using Terraform Workspace. So how's that work here as well? So what we're going to do is we're going to run the deletion on the Terraform Cloud side. So all we need to do is copy out our workspace name, toss that in there. That's going to kick off. There it goes. So then we can jump back to our terminal over here. While that's running remotely, we can do a Terraform workspace list. And then what we want to do is move from our HashiDog over to our HashiCat, which is just a Terraform workspace switch. Oh, no, sorry, select. Difference between Git and difference between Terraform. Okay, so there we go. On that, we've got our plan running, have our confirm. Just going to let that run right through. And we can continue running this, check, make sure nothing's changed on our HashiCat side. Because this will generally take just a couple seconds, or really about a minute or so, to go through the removal process. Though another thing, so I wanted to talk about how we're using filters as part of our cloud block there. And so, or rather tags as part of our cloud block. So what those line up to are this tags block that's over here on the right-hand side. This is also available in our Workspaces overview page. So you can see all of these new workspaces that were created all have that same tag that's been applied to those. You can also, it's a list, so you can apply pretty much whatever you want to. And those can align with some of the other areas. It's really nice because from the visual aspect, especially once you get into some of the larger environments, you can filter as well. So in this case, I can say, I just want to see the ones that are marked as service-Azure. It even updates our URL at the top, so we can bookmark that. So we only see this as part of our overview. We can also add more. So we could, if this ended up being a development environment, we could tag it with development. We could give it a totally new, say, sandbox, call it sandbox, and then it shows up as well out there on our Workspaces page. So with that, let's see where we're at here. We've got our subnet that's being removed. Where is our virtual machine? Our virtual machine's already gone, so this should be wrapping up pretty quickly. The virtual network and then our resource group are pretty much all that's left. So what we can do is if we go back to our website here, that unreachable, so it's gone, we've cleaned it up, it's no longer available. And now we want to go back through and actually clean up this workspace itself, which there we go, our apply is finished. So now what we can do is oops. So now what we want to do is clean up that workspace itself. So we're going to delete that workspace. So Terraform workspace delete, and this is so after a couple seconds here, there we go. We see our workspace has been deleted. So we are all set there. And if we go back to our Terraform Cloud environment, we actually see that that workspace has also been cleaned up within our Terraform Cloud environment. So it really provides the entire life cycle of a workspace within Terraform Cloud in just the same way that it would locally by using Terraform's, the open source workspaces as well. So with that, I think I have talked for long enough. So let's go ahead and dive into some Q&A. Actually, do want to cover one more thing first before we dive in.
Oh, yeah.
So we do have a lot more information. So before people drop, in case they don't want to listen to the Q&A or listen in on that, we do have several resources that are out there and available right now. First and foremost, the announcement blog that's out there talks about all the things that Corinne went over, as well as some of the things that I went through. We also have the change log, so that's going to provide you an in-depth look at everything that's changed, updated, been removed, what have you, for every single release, not just 1.1, but there is one specific for Terraform 1.1, and we're currently on 1.1.4. Then we also have 2 learn guides that kind of build on the demo that I just showed, where they show you or provide a walkthrough on how to move some of those resources within your own configuration and update state files using that move block, as well as even migrating state over to Terraform Cloud using that cloud integration. And it also works if you're using backends today or even enhanced remote backends to move it to the cloud integration. So those are great resources to kind of provide you that guided walkthrough on how to make that happen. All right, so sorry about that, Michelle. Over to you for Q&A.
No worries, great job. All about cats and dogs in demos. This makes the world a happier place. So we're gonna get into some questions. One that came up a lot, does this new cloud block work with Terraform Enterprise? I'm gonna go with Corinne.
Yes, it does. The new cloud block is supported both for Terraform Cloud and Terraform Enterprise users.
Yep.
Okay,
so
great.
I'll throw in the caveat there that there is the host name that's out there, and you just change that. The default is Terraform Cloud. You just change it over to whatever your Terraform Enterprise URL is, and you're all set and ready to roll.
Cool. So this one came up a few times. After the move statement has been executed, can it be removed? In other words, is it a one-time move and state resources are now updated?
Yeah, so that's a really good question. I would recommend looking at the documentation. We strongly recommend that you do not remove moved blocks, as 1, they provide a historical record, and then 2, if someone like an end user has an older configuration version, they encounter you're updated and they don't have those moved blocks any longer, it'll just recreate the objects exactly what we don't intend to do. So typically we recommend to keep the moved blocks. However, if you do want to remove them, we have documentation. I don't know if we want to supply that during in the chat, but we have documentation that advises about how to do it safely. And additionally, if you have a series of, I want to move, rename a resource, and then I want to rename it again, you can do change move blocks, and that's supplied in our documentation as well.
Great. So I went ahead and plugged that. Oh, I forgot an H. Let me go ahead and plug that in the chat. So people have what they need. One sec. There we go. Cool.
Additionally, if you want to see like the full workflow, I know that Kyle showed a demo. We have that Learn tutorial. We'll show you how exactly this all feels. You can see the different use cases in the documentation as well.
Cool. All right. Are there examples of moving resources or modules that use the count or for each resource?
Yes. So again, I recommend looking at the documentation. There's a few examples in there if you wanted to see how you could enable count for each for a resource or a module and what the workflow should look like.
Cool. Excellent. Let's see. Is there a more dry method to move resources, or are they all one-to-one?
Right now, everything in our documentation includes the use cases that we have for the moved blocks. This is our first iteration. That being said, we are always looking for more use cases to expand, especially for things like how do I keep my configuration dry? So with that, you are always free to add me on LinkedIn, or you can find me on Twitter, and I can set up a call and we can talk about more your specific use cases and walk through different ways we can get around this.
Okay, all right. While the move brackets code is in place, then the resource can be referenced by the from address to the to address, i.e. the process at a high level would be you'd write your new module code, you'd add the move block, you'd rewrite your root code, and then finally you would remove your move code. Is that the process?
The process from a high level is correct, except for removing the moved blocks. And again, I would recommend trying out the tutorial just to get a feel for how this all works. Just seeing the demo, it might not quite get the interactions, but when you try it out, it's pretty clear like how it all comes out in the end.
Great. Is it possible to move a resource which has already been moved before?
Yes. So I mentioned that in the documentation, we have a section on change move blocks. So you can say a series of moved even on the same resource or module call that it's been renamed, or those kinds of changes.
Okay, let's find some more. One sec. Once a move has been executed, is it okay just to leave it there? Will there be any messages that state there is nothing to move, or will it be silent?
It'll be silent. So if it doesn't encounter any configurations that include those older state objects, nothing will happen. If it does, it'll give you a plan to say this is what's going to change. You have these move blocks, etc. But otherwise, they're just there in configuration.
Okay. Will the new remote backend configuration, or the cloud block, will it support partial backends and allow passing of the configs during runtime?
No, so that's a really good question. We actually are still investigating this use case right now. I'd really recommend you reaching out to me on LinkedIn and we can talk about your use cases. Currently, the cloud block does not support partial configuration, but the remote backend still does, and we did not deprecate the remote backend. So if you upgrade to Terraform 1.1, the remote backend is still there, you can use it. And so if you're relying on partial configuration, a lot of people use it with their CI systems. Don't migrate to the cloud block, but please reach out to me and we'll talk about how to give the same capabilities with the cloud block. Therefore, like when we release new features, you can upgrade, and we will definitely not deprecate the remote backend without supplying ways to give partial configuration.
All righty, well, here's another one. Someone's curious if there will be an imported block that can be used just to import resources and config, just like moving them.
I wish I could give you more details about what we're planning, but I cannot. If you would like to chat about this, definitely reach out to me and we can set up an NDA and talk about any future plans, but at this moment, I can't give any information.
Okay. Do users get the structured output if they run a plan via the CLI?
Yeah, no. Kyle, you jump in.
No. So if it's so the way that it works on the CLI runs, it's still making use of the standard output. So you're not seeing the structured run output or actually I just destroyed my workspace that was showing the structured run output. But if you run subsequent workflows within Terraform Cloud, it'll make that automatic jump over to using the JSON format, which gives structured run output. And structured run output, for those of you who may or may not know, is kind of that that more UI friendly kind of output of like when it was going through and destroying the resources within Azure. It had like a little Azure symbol and it had the resource and resource ID. That's what we mean by structured run output. It's just a little more friendly way to view that in the UI. There's no actual change into the way that the Terraform runs, operates, or anything of that nature, but it's just a way that it differs when you look at that run output in Terraform Cloud itself.
Thanks, Kyle. I misunderstood the question, so thank you for jumping in.
Cool. So I'm going to rephrase this. If someone were to describe the benefits really quickly of using the new cloud block versus the existing remote block, what would those two statements be, in case somebody missed the beginning?
Sure. The main new improvements is just better error messages and handling. You can use configure workspace tags via configuration, whereas before you could only do names and prefixes. And secondly, you can use things like -var, flags. You can supply input variables. I also saw a question, I think, that was asking if you do supply per run variable on a workspace run, will it update your work variables in the UI? No, that's a per run variable, so you're just executing it for that one run. You could go in though and actually update your variables if you wanted to be like a consistent variable.
Okay, and so the second part of this question, is there a need to move to the cloud block because of deprecation or anything of the sort? What should they anticipate there?
Not at this time. Terraform 1.1 supports the remote backend and the cloud block, and we are not currently deprecating it. However, when we come out with new features, it will only go to the new cloud block. So we want people to obviously upgrade to the new cloud block. However, we're researching all the different ways that maybe people aren't able to move up right now.
Okay, this is a question, I guess I'll give this to Kyle. So variables have been around for a while. With the introduction of variable sets, are environment variables still available?
Yes, so the question is around variable sets, and yes, you do still have the same option of doing either Terraform-based variables or environmental-based variables as part of variable sets. So in terms of that, they function exactly the same way.
Okay, should this content be expected in the Terraform Associate exam? Do we know? Good question.
So we're actually going through and updating some of that right now. The expectation that I believe I can talk about is that everything is going to be 1.0 and newer. So while I don't know if we will specifically ask about some of these things, but if we do, there is the requirement of having to specialize out in say in version of Terraform 1.1 using the cloud integration or using the move block. Then so that's what you can kind of expect if those were to make it into the Terraform Associate exam.
Okay,
Again,
so somebody
asterisks.
Okay, asterisk. Somebody also asked, just along that line, for those who are not familiar, could you give more details about any kind of Terraform certification?
Yes, if somebody has a chance to drop a link to it, we do have a certification program, and one of which is what's known as the Terraform Associate exam. It's multiple choice, true false style questions that basically test your knowledge to a associate level on using Terraform. So there is a study guide that's out there available on the Terraform documentation page that kind of walks through the expectations and what that kind of looks like. For those of you who just heard me talk about updating to 1.0, we are not there right now. Currently, it is still 0.14 and above, I believe. And that's there's more information. Hopefully, somebody can share a link on that in the comments. But kind of a really cool way to show off that you have used and know and understand at least the basics of Terraform. And you get a Credly badge, I believe.
Cool. Let's see, we have a few more. Grab. So to clarify, so just back to the demo, if somebody wanted to delete the cat workspace from the CLI, what happens to the deployed resources? That's the file.
Great question. I'm pretty certain they still exist. When we destroy the workspace, I'm pretty certain they just, it removes the state file, removes the information that Terraform understands about those resources that have been created, and those continue to exist out in Azure. Obviously not something that you would want to do accidentally.
Okay, well, thanks so much for answering all these great questions. Just to clarify, if you haven't downloaded Terraform 1.1 yet, go to terraform.io/downloads, or just the downloads page on terraform.io, and you can download it there and try it out. There are some learn guides. If you haven't already signed up for Terraform Cloud, you can do that at cloud.hashicorp.com and just find Terraform there and get started. If you missed any part of this session, you will receive a recording of this in a few days in your inbox. So thanks so much for